Hi, welcome to another lesson with Dr. Hill. Today we're talking about uh, electronic circuits, and we are going to move on to measuring electrical current. Now, we've previously done some measuring of our circuit, and the last time we looked at voltage. Now, voltage is divided up amongst the components of an electrical circuit, and generally what we have to do is we have to measure voltage by connecting our voltmeter to either side of each component. And that's what we did in our previous lesson. If you didn't catch that, go back and have a look. Now, we'll have a look at that on the board here, and we'll see what that looks like. So this was our method of measuring voltage here. This is the lesson. So we measured voltage by connecting our voltmeter across the component. This is just a light bulb in a simple circuit, right? But current can't be measured that way because the current is the flow of electricity through the wire. And so what we have to do is we have to completely interrupt the flow in order to measure what current we're getting. So let's have a look at how we would do that. So let's take our battery. And again, what we're going to do is we're going to have a light bulb down here. There it is, that's the light bulb. And in order to measure the current flowing, I have to break this circuit and put my meter into it. So what I'm going to do is I'm going to connect my ammeter, which is the thing that measures current, directly into series with the light bulb. It's called being in series. This is connected in parallel, this is connected in series. But while we say it's connected in parallel, what's really happening here is the voltmeter is connected across the component. And the ammeter, the measuring current, is in line with the flow of the current. The current has to flow through the ammeter. All the current in this wire has to flow through the ammeter before it gets out the other side and back to the negative end of the battery. So with our circuits, excuse me, we can test using the conductivity tester that we used last time, because essentially our conductivity tester, and I'll just take you through this circuit again, because I remember I didn't really take you through it last time. We've got the positive coming out of the battery onto this rail of the breadboard, goes through a resistor to column 21. Column 21 is connected to the long leg of the LED. The short leg of the LED is in column 17, and column 17 has got this jumper lead connected to it. So the electricity is coming out of the battery, through the resistor, through the LED, and out to this white wire. And we used this method in our last lesson to test conductivity. I realized when I looked at the video last time that I'd actually electrocuted the Queen. Sorry, Your Majesty, we'll just turn you over and we'll electrocute this dude on the other side. So, and we got our connection, okay? So the $2 coin connects up the circuit and completes the circuit. Now that essentially allows me to do a very quick test of the current of this circuit, because I can connect my ammeter in between these 2 points, and we'll see what it looks like. So if I was to just carefully put those two things down here, I can bring in my ammeter, which is a little bit tricky to get everything on into the video, but let's see. And here are my two ammeter connections, and what we're going to do, I've set my ammeter to millivolts. Actually microvolts might be better. So and I'm going to connect up the red end of my multimeter to the positive, and with any luck I can connect up the, and what we see is we have 1469 microamps, or 1.4 1.5 milliamps going through this circuit. 1.5 milliamps going through the circuit. So 3 volts, 1.5 milliamps. So I've measured the current going through the circuit. Now, if I was to take the resistor and change the resistor to something else, I'll get a different current. And that's how we adjust the current in electrical circuits. And resistors is the thing we're going to come on to next time. But I need to connect my ammeter, which is my multimeter here. I got a new one. It's pretty good, isn't it? My ammeter here directly, and the electricity of the whole circuit has to pass through the ammeter and out the other side in order to be measured accurately. And there we have 1.5-ish milliamps, or 1470 microamps, which is what that scale is at. So it shows that we've got quite a low current flowing through our ammeter. It's with a small battery pack like this, it's a relatively safe current for handling. But remember, always, when you have your connection, your electricity connected up, don't touch any of the metal parts of any circuit, ever. It's a good habit to get into. And if you do need to touch the metal parts of a circuit while you're connected up and running, you need to be using something that is fully insulated between you and the circuit. So you should never be touching the conductive part of the circuit. All right. So that's how you measure amps. And we'll find that we have, what was that, 1.5 milliamps going through that circuit, which isn't very much, but it's enough to, and it's a nice safe amperage for our nice safe current for our LED, and doesn't blow the LED. If I was to allow anything around 200 milliamps to flow through that LED, I would destroy it. Okay, so it's important to get the current right, and if you ever need to test how much current is going through it, you use an ammeter and you connect it in series. Okay, so that's the end of this lesson. I'm just demonstrating that, and when we get back to school we'll test it in the lab because we have plenty of ammeters there. If you have a multimeter at home, you can try using it. You need to follow the instructions to get it set up correctly for your to measure current. If anybody wants me to make a video on how I've set mine up, I will. I'll do that, but you need to ask me. All right. So I'll see you in the next lesson where we're going to start talking about switches. Okay. So I'll talk.